What's going on, everyone? Don here with the Physics Instructional Resource Team, and I've got another demonstration for you today, this time talking about series and parallel circuits. So our setup here is just a bunch of light bulbs. They're all the same, so they all have the same resistance and wattage ratings. And we've got this power supply. And on this side, coming out of the positive side, we can set some potential value, some voltage. And on the other side, coming out of this black wire, this is the zero or the ground value. And so there's a potential difference of, when I turn this on, it'll be 10 volts, and it'll want to make its way through this circuit in a particular way. And if you remember from Ohm's law, we know that voltage through a circuit is equal to the current going through it times the total resistance of the circuit. And we can use this, and I'm going to avoid numbers in this video, but we can use this to kind of understand how Ohm's law works in different configurations of these circuits, namely series and parallel. So in a series circuit, we have the electrons going through one element at a time. And so we're going to start off with one light bulb here. Right now this is set up so that electrons will flow through this light bulb because it wants to go from high to low potential. And it'll go straight from here all the way to the low potential. No reason for it to go through any of these light bulbs because they're all resistors. So when I turn this on, we get a certain brightness coming from the light bulb. And this brightness is associated with current. So we have a voltage going through the circuit, we have the resistance of the light bulb, and we have a current going through it. And these are all related by Ohm's law. Now, if I were to add a second current element, or a second circuit element, let's say this second light bulb, I would remove this guy, turn the potential, zero potential over to here, and now it'll want to go through this way. And so we should see both of these light up. And what I want you to notice is that they are way dimmer. And the reason for that is because in a series circuit, the total resistance is equal to the resistance of each component added up with each other. And so basically the resistance went up by a factor of 2, which means that the current was reduced by a factor of 2. And we see that as a dimming of the bulbs. And I can go one more here by removing this guy. Now it's going to go through these 3 light bulbs. And if I turn it on, there. I don't even know if you can see that on the camera. I think you can, but you can see that it gets way dimmer. Now we'll talk about parallel circuits. And in parallel circuits, we are giving the electrons more than one path to go through. So it can go through multiple components at the same time. Instead of going through one light bulb at a time, we're going to set it up so that there are 5 paths for the electricity to flow. And so I'm going to just connect these guys here. And now we can see that the high potential is connected to this side of the light bulbs. The low potential is connected to the other side of the light bulbs. And when I turn this on, we'll see that the light bulbs are all pretty bright. And with Ohm's law, that tells us if the light bulbs are bright, the current is high, that means that the resistance must be low. And we can find it out experimentally. I won't do that here, but experimentally we find that resistors in parallel, the total resistance is actually the reciprocal of the fractional sum of all of these components. So 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, so on and so forth. And that is the case for parallel light bulbs. And that in a nutshell is Ohm's law and series and parallel circuits.